Hello, we have a mixed operations problem again for you today. It mixes multiplication and addition and subtraction. Thus, it's a mixed operations problem. So the problem we've got before you today is 1 minus 2 times 3 plus 4 times 5. All right, 1 minus 2 times 3 plus 4 times 5. If you'd like to at this point, you can pause the video. You may already know the answer. You might be working it through, but we'll pause it and then come back and work it out together. All right, so hopefully you remember your order of operations convention. Step number one is parentheses, or if you're familiar with BODMAS, BEDMAS, BIDMAS, you might refer to those as brackets. Basically, those are just grouping symbols that tell us to solve anything inside of those parentheses or brackets first according to the order of operations. Well, it's pretty clear we don't have any of those, but does that mean we throw away the order of operations? No, it doesn't. A lot of people mistakenly think that. I will hear people always say, well, if there are no parentheses, you just solve left to right. But unfortunately, they forgot the order of operations because they forgot that multiplication is still here, and multiplication does have precedence. All right. But if you go through the normal order of operations, you've got another step, step number two. Typically in the acronym PEMDAS, you would refer to step two as exponents. With BODMAS, the O represents orders. Orders really is kind of a more generic term, which I like. It actually includes the exponents, factorials, and square roots. And don't worry if you don't remember what factorials are. It's just a shorthand method for multiplication as well. It uses an exclamation mark at the end of a number. But basically, your exponents, factorials, square roots, these are anything that is shorthand for repeated multiplication. That would be your second step. Well, again, we don't have those either here, right? Does that mean we throw away the order of operations? No, it does not. We still move on. We move on to step number three, which is our multiplication or division, left to right. Remember, multiplication and division have equal precedence. It's not one before the other. You just go left to right. Remember, division is the same thing as multiplying by a reciprocal. So they have equal precedence. Well, here we do have some multiplication. We do not have any division, but we've got this 2 times 3, and we have this 4 times 5. So what do we do then? Well, after we would solve the multiplication here, we look at addition and subtraction. Again, addition and subtraction have equal precedence. A lot of people get confused with PEMDAS and BODMAS, and they try to tell me that addition comes before subtraction, and that's not true either. The letters, it's a memorization tool, but it doesn't literally mean addition before subtraction any more than multiplication before division. All right, so we said multiplication is repeated addition, and I know I keep repeating that concept, but it gets lost. Not with everybody, but some people they get confused with that. But basically, multiplication is going to get solved first. 2 times 3 is 6. 4 times 5 is 20. So this becomes 1 minus 6 is minus 5. You have negative 5. Negative 5 plus 20 is 15. 15 would be the correct answer. Remember, parentheses are not required here to give multiplication precedence. I know a lot of people would say, well, yeah, the answer would be 15, but you would have to put parentheses around the 2 times 3, and you'd have to have parentheses around the 4 times 5. Well, no, that's not true, because multiplication already has precedence. Multiplication's repeated addition. So how do we prove that? Well, that's pretty simple, actually. You can replace multiplication with equivalent addition or subtraction, right? Because what is it after all? Once again, multiplication is repeated addition. Think of it like shorthand. It's a shorthanded way of writing repeated multiplication. It's a lot easier to write 4 times 5 than it is to add 4 5 times. 4 times 5 is the same thing as adding 4 5 times. 1, 2, 3, 4, 5. 2 times 3 is the same thing as adding 2 3 times. Now keep in mind, we have a negative sign in front of the 2 times 3. So in this case, negative 2 times 3 is the same thing as subtracting 2 3 times. So if you have 1 minus 2 minus 2 minus 2 plus 4 plus 4 plus 4 plus 4 plus 4, woo, that's actually 15. I've got an extra 1 on the end of that. So we're going to fix that while we are writing that out. That's extra 1 got stuck in there. That is actually 15. 15 would be the correct answer here. All right. So let's move on. Now, a lot of people say, well, wait a minute. I just pulled out my calculator that I bought at the Dollar Tree or Dollar General or uh, bargains and buyouts, whatever store, the grocery store checkout, or I used the standard mode calculator on my Windows computer. That ought to be right, huh? That ought to give me the right answer of 5. Well, no, that's not true. You have to keep in mind, you need to really understand how your calculator works. And I'm going to just jump ahead one slide here just to let you know. You need to understand how your calculator works. You need to understand your calculator and how to use it properly. There's something called immediate execution mode. There's something called expression mode. These are the two common input types for calculators. Now, this is from a Windows 11 computer, both of these examples. In the one hand, the calculator app on a Windows computer is placed in scientific mode, which in scientific mode, this calculator works in expression mode, meaning that you can enter the entire expression 1 minus 2 times 3 plus 4 times 5, press the equal sign, and you get the correct answer of 15. But if you're using it in standard mode, and Microsoft does a really poor job of explaining it. I don't know where it's explained. You can find more information online about this if you want to look into it. But in this mode, this calculator is working in what's called immediate execution mode, not expression mode. And what that means is as you type 1 minus 2, it's going ahead and saying, well, 1 minus 2 is negative 1. And then it's saying negative 1 times 3 is negative 3. And negative 3 plus 4 is what? Negative 3 plus 4 is 1. 1 times 5 is 5. Now look what happens here. I entered these numbers in the same way. All right, on the left side, I entered 1 minus 2 times 3 plus 4 times 5, then the equal sign. Notice how the entire expression still sits here. On this side, the only thing I'm left with, and I typed it the same way on this mode, the only thing I'm left with is the 1 times 5 equals 5. So this is incorrect, but the way that you need to understand how to use a calculator in this mode is that when you have immediate execution mode, you need to do the higher precedence operations first. You actually manually have to multiply the 2 times 3 and then the 4 times 5 and then do your addition and subtraction after that. So that's the problem, and a lot of people don't understand that, and they try to tell me that their calculator gave them the answer of 5, so I don't know what I'm talking about. But please, please understand your calculator. Yeah, the answer was never 37, because that's not the answer to this problem either. The answer was never 5 in this case. The answer was never 5 back in your day, and that's a common excuse when people have forgotten what they were taught. All right, there's plenty of old textbooks out there. There's no textbooks. I've challenged people, please show me your textbook that told you back in the 60s you blindly solved left to right. Nobody's been ever able to do it because no such textbook exists. There's no textbooks out there that ever said, just blindly solve left to right. You're good. Good to go. I mean, the order of operations really is centuries old in Western civilization. The roots go all the way back into the 16th century. We're talking the 1500s. All right. Again, here's a 1950s textbook. And in this 1950s textbook, they are pretty clear. It says, parentheses and the other symbols of inclusion are the customary means used to make clear the meaning of a numerical expression. However, mathematicians have agreed on a rule to fall back on if someone omits punctuation marks, parentheses. This rule gives the order to be followed in performing the operations indicated in the expression. The argument implies, for example, that, and it goes through all these different examples here, like 5 plus 3 times 2. The answer is 11 because you're solving the multiplication before you add. Right there, 1950s. You know, it goes right through here and it says in a numerical expression containing a series of numerals connected by symbols of operation, you agree to follow this order. Number one, simplify the expression within each symbol of inclusion, meaning parentheses or brackets. Step number two, perform the multiplications and divisions in order from left to right. Step number three, finally, do the additions and subtractions in order from left to right. That's all the way back from the 1950s, folks. 70 some years ago. They knew it then. Unfortunately, people forget what they were taught. I get it. It happens. Here's a 1920s textbook, okay, going through all this stuff. And they mention about the order of operations, and they even give two great examples. Right here it says, thus, 12 minus 10 divided by 2 indicates that 10 is to be divided by 2 and the quotient is to be subtracted from 12. This gives 7 as a result. Notice what they did there. They did the division before they subtracted. It doesn't matter that the division came last. Division has priority. In like manner, here's another one. In like manner, 4 plus 6 times 3 indicates that 3 times 6 are to be added to 4, which gives 22. 6 times 3 act as if in a parenthesis. So, yes, that's true. Some teachers used to tell people, go ahead and put parentheses around the multiplication just to make sure you understand that you do that first. Now, those parentheses are redundant. I don't have to put parentheses around the 6 times 3. Doing so is redundant, but you certainly can do that. It doesn't change the answer. The answer to that problem is going to be the same. 1913 textbook right here. And please don't be confused that this comes from an algebra book. The order of operations convention applies to algebraic and non-algebraic equations as well as expressions. I've had people try to tell me, well, wait a minute, it only applies to algebra. Well, that's not true. That's never been true. I don't know where people got that idea. But right here, this section, the fundamental operations are addition, subtraction, multiplication, and division. Indicated operations are to be performed in the following order. First, all multiplications and divisions in their order from left to right, then all additions and subtractions from left to right. So there we have it. We've got the 1910s, 1920s, and the 1950s. They all agree. If somebody out there has a textbook from back in your day that tells you different, please send me a link to it. I'd love to see it. It doesn't exist, and I keep challenging somebody to show me one. But I hope this has been helpful. I hope that maybe somewhere along the line you've picked up some new information. Maybe you have never realized that calculators do work differently. That might be something you've never seen before. But if you found something valuable from this video, please consider liking, sharing, subscribing, sign up for notifications, and share it with your friends. If someone has a question on one of these problems, feel free to share the video. That's very helpful. But I do look forward to seeing you all in the next video.